Oh wow, this is incredible. I can't believe GLM was able to build this. So every dot you're seeing on the screen here is all of the asteroids that are going to be coming near Earth in the next 10 years and their orbits. And of course, we have our solar system here. I can't believe it was able to build this. This is truly incredible. All of the data is based on the Jet Propulsion Laboratory from NASA that GLM was able to pull. So this is all real. So as you can see on the left-hand side, it gives you exactly all of the upcoming close approaches and their orbits. I can click on any of this and it'll show me exactly where the orbits are. And then of course I can hide the orbits of the asteroids so that way you can just see the solar system. This is way cooler than I expected, actually. Again, the reason why I built this is because I've been seeing these different charts. Especially this one was very interesting in Design Arena. So these guys rank all of the models based on front-end designs and web development. And GLM 5.2 is crushing it. What surprised me is that it's even better than Fable 5. I mean, slightly better, but still, it's actually incredible that a open source model is able to build incredible designs and things like this that are actually based on real data. So in this video, I'm going to show you exactly, first of all, what this thing is, because this is so cool. Like, I'm a space nerd, so I'm nerding out here a bit. But the reason I built this is because, you know, when you're building something cool, that's the best way to learn, right? So building something like this is not only fun, but it's actually something that you can test these models with, right? So I'm going to show you exactly how to install GLM 5.2, what it is. We'll go through the different benchmarks. And of course, I'm going to show you how to build this and give you the prompts and everything else for free. All right, so first of all, let me actually go through and show you what's going on here because this is so cool. So I'm just going to hide the orbits of the asteroids first because I'm going to show you how obviously this is our solar system on the top right hand side there. That's another galaxy. But you can see this is our sun here, and it was able to grab these pictures, the actual pictures from NASA. And then also obviously that's Earth. You can see that's their orbit, Mercury, Venus, Mars, and then Jupiter all the way here. And these other guys, Neptune, Saturn, they're all the way. If you can see Neptune and Saturn are barely moving, but that's because they're orbits are really wide. But anyway, so this is basically our solar system, obviously. So now I can click on all orbits, and this is going to bring in all of these different orbits of the asteroids. So the smaller ones, obviously, these are all the different asteroids, and you can see the timeline right here. As you can see, sim date or simulation date, it says 2063-7. So it's basically 10 days per second. So when you're seeing this, it's 10 days per second. On the left-hand side, you'll see that it says NASA JPL Small Body Database, poll 2026. And then I can, you can see I can click on this. It's going to select the orbit of each of these different asteroids. And then on the left-hand side here is going to show you how many dots or how many asteroids are plotted, right? That's 4,500 plotted. Now this Apollo, Athena, Amor, Atira, and Brighter. These are all the different asteroids, their orbit, and how close they cross the Earth right here, right? So for instance, the Apollo, these are the most common, therefore there's 3,000 of them. Now their orbit is bigger than Earth's, but they swing inward and cross our path. So again, these are the most near to Earth, the orbits that are coming in. And then Athene, which is the teal colors, there's 250 of them. Now these are mostly, they mostly live inside Earth's orbit. They're closer to the sun, but they swing out far enough to cross our path or Earth's path as well. And then on the top right-hand corner here, because I've activated all orbits, if I just say hazardous, so these are all of the ones that are potentially hazardous that are going to be swinging by near Earth. And again, like I said, I'll put the link in the description for you guys so you can check out. This is based on the real data that I pulled from I had the LLM pulled from the Jet Propulsion Laboratory from Caltech there, which is in California. Again, all part of NASA there. And then on the bottom here, these are again the upcoming close approaches. So you can see exactly the dates and everything. So there's a few coming in near in June, August, October. And these names, these are just basically their kind of names that they put when they were discovered. So the 2026 LK1, it just means that this is where it was discovered. And again, I don't know too much about obviously how they named these, but it just looks like it's all based on when it was discovered. It shows that. But I kind of like that you can, let me just go back to the Earth. You can kind of zoom out and you can see clearly kind of the objects rotating. That's very cool. So anyways, so this was something that I just built just for fun, right? So I'll show you guys how to, I'll give you the prompt in a little bit. But let's go ahead and first talk about GLM 5.2, why it's kind of right now blowing up everywhere. So one of the things I want to focus is, and I'll put again the link in the description for this, you guys can check this out as well. Now, Designer Arena is one of the top kind of intelligence companies that compares different models. So a lot of times they're focused on the front end and web developing and design. So that's why, like I said, I wanted to show this because, of course, if you're building websites or doing things that have anything related to design, these are the guys that kind of rank the different models. And like I mentioned, they rank GLM 5.2 better than Claude Fable 5, Opus 4.6, 7, and everything else. I don't know why they don't have Opus 4.8 here, but I would imagine if this is better than Fable 5, then it's definitely better than Opus 4.8 there. So you can see there are different categories that they rank as far as the code categories, preference versus speed. You can see that the different models are there. So again, check that out, and you can check out the different leaderboards here as well. And you can see there's a front end and full stack. You'll see which models are leading the pack there. But if you go back to the code, right? So you can see it's just designerarena.ai leaderboard /code. So this is the code for the front end ranking, and GLM 5.2 is doing a lot better than anticipated. And of course, these are the LLM performance evaluation as far as the overall, the 8 typical benchmarks that they, rank these models on. Again, GLM 4.2 or 5.2 is doing really well compared to paid models, right? Like Anthropic and GPT 5.5 and Gemini, again, in all of these different metrics there. So absolutely incredible, the fact that this is an open source model, and essentially you can run this on your local machine. That's kind of the whole point of local models or open source models. But because this is a huge model, I think it has 700 and something 60 billion parameters. One of the best things to do is to use some kind of a rented online, right? Because if you don't have the infrastructure to run this, I mean, if I download this into my machine from, Olama and everything, it's going to completely destroy my machine because I don't have the hardware. So one of the things to do is to use these models through something like an OpenRouter, or for instance, through Z.ai, right? So this is Z.ai, where you can actually use the GLM directly here on their interface, but you have to obviously pay for that, for their plan. But it's way cheaper, like when you compare the pricing actually of GLM 5.2 versus Claude Opus 4.8 and your Fable, of course. I mean, Fable is right now banned, but it's still way cheaper. So if I go and take a look at GLM 5.2, you can see, so it's $1 per 1 million input and $4 per 1 million output. Now, if we were to compare this to, let's say, Fable 5, right, it's $10 per 1 million input token and $50 per 1 million output. So it's 10 times cheaper than Fable 5. And of course, Fable is right now not working. But still, I mean, even if you take a look at Opus, for instance, right? So if I do Opus 4.8, it's $5 and $25. So still 5 times cheaper than your Claude Opus 4.8. And it beats them in a lot of metrics. If not, at least it's on par or close by. So now let me go ahead and show you how you can use this inside your Claude code, actually on an IDE like a Visual Studio Code, right? So by the way, as you can see, I just kind of built this whole thing from Claude Code through the GLM 5.2. So I'm going to show you how to build this, or how to use this inside Claude. So first thing to do, obviously, you need to install. So let me actually get rid of this. We'll start a new one. So first thing to do is install Visual Studio Code. Again, this is just an IDE, which stands for Integrated Development Environment. It's a way for you to use Claude Code inside this cohesive environment and have all of your files and everything in the same exact place. So go ahead and install your Claude Code, your Visual Studio Code. It's completely for free. Then you're going to come here on the left-hand side. You can go to Extension, install Claude Code for VS Code there. So once you come here, right, you're going to go back to the files here, and here you can create an entire new folder, right? Once you create an entire, click on new folder, you can name it .claude, right? Something like that. I already have that, so that's why it's not allowing me. But once you have that, then you're going to click on it and click on a new file and do settings.json, okay? And again, because I already have that, that's why it's not allowing me. So I'm just going to delete that. So this is what it's going to look like. So once you have this, so let me Bring this over. Once you have the settings.json, obviously here, this is not going to be there for you, but this is what's the important part here. So what you want to do is just basically copy paste this. So again, I'm going to put this in the description of the video, a file where you guys can have access to this completely for free. So you want to basically copy and paste that in here. So because we're using the GLM 5.2 through OpenRouter, you want to have this entropic base URL as https openrouter.ai/API, because obviously we're going to need an API key, because again, normally this would be Entropic's base URL, so it'd be entropic.ai, I believe, /API, and then you would have to put your Entropic authorization token. And here, what we're going to do is just basically switch the base URL to OpenRouter, so now we can have access to different models through OpenRouter there. As far as Entropic authorization token, this is where we need to now put our API key from our OpenRouter. The way to do that, very simple. You're going to head over to your, OpenRouter account, right? Go ahead and create a account here. You need to have some credits in there. So just go ahead and put like $5 or something like that, right? Or $1. Actually, just put $5. I think that's because you're going to be able to use that with different models as well. So once you have that, you're going to click on your profile, right? If you can come here in your account, click on profile, you can go ahead and click on API keys here. And in here, you can do new API key, name it something like API key for Claude, right? Or whatever you want to name it, right? Rate limits, just leave it as it is. Credit limit, leave it as blank. Expiration date, of course, for you, it's going to be it's not going to be an expiration. You shouldn't have an expiration date, but I'm going to keep it as 1 hour because otherwise I don't want anybody to copy and paste this. So once you click on create, now you have your API key. You're going to copy this. You're going to come back inside your Claude code here, and you're just going to basically replace this thing. Let me get rid of it, and then just paste this, and now you have your API key there. Now you should be able to use all of the models inside OpenRouter through this API key. So in order to use the GLM 5.2, you're going to come to the bottom here and just replace. I mean, don't touch this because you can just copy and paste it from the description of this video. But essentially, we're using it through Z.ai/GLM 5.2, right? That's you're going to leave everything as exactly is. Again, this one, you're not going to have this. After you actually build something, it's going to ask you a few permissions, and these bash curls are going to show up afterwards. So that's all you need to do. Just make sure you save this, and then you'll open a new Claude code, a new instance of Claude code, so that way you have the ability to interact with this GLM 5.2 model from within your Claude code here. So now, if I click on slash switch models, right? If I click on switch models, you can see it's already now our default models are 5.2 here. So now if I just say hello, I just want to make sure that it's working, right? So it should be able to, now there you go. Hello, I'm Claude Code, ready to help, blah, 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 right? Great. So it looks like everything is working. Okay, so now let's go ahead and actually try to build something, right? So in order to do this, all I have to do is just paste this code. So I'm just going to say, build me a cinematic interactive 3D visualization of the near-Earth asteroid swarm, every asteroid whose orbit comes close to Earth, using real NASA data as a single self-contained index.html file, right? So I'm saying data, free, no API key, pull the orbital elements from near-Earth asteroids from NASA/JPL, small body database query API, which is exactly this right here. So this is the SB small body data API. Again, it stands for SBDB Small Body Database API, provides a method for requesting machine readable data for a specified small body within JPL's database. So that's exactly what we're doing. Basically, we're saying that use this endpoint, right? So I'm telling GLM from Claude Code, hey, instead of me actually doing things manually, just pull the data from this API, which is exactly the link that we just looked at, right? And we're giving it all these different kind of terminologies. Again, I had to go back and forth a lot to figure this thing out, but this basically gives it everything it needs. So I'm saying include all potential hazardous asteroids plus the largest of the rest, 4,500 total. Pull upcoming Earth close approaches from JPL, blah, blah, blah. Physics, I'm saying make sure it's real, not decorative. Every frame, everything should be real. The look and feel, and giving it a design detail. And this is where, like I said, the GLM 5.2 really shines as far as giving it design and everything else through code, just like we saw in arena right here in design arena. So that's why you want to make sure you're giving it more detail, and it'll be able to really create stunning and beautiful visuals here. So I'm saying interactions, giving it kind of like the data for, or the instructions on how I want to interact with this. I want to drag and rotate, scroll, zoom, all of that good stuff, right? So you just basically go ahead and enter this. So after a while, this is going to go ahead and use your tokens and everything. And after a good couple of minutes, so since I've already built this, I already did this. So there you go. So it says I'm going to go ahead and go through. So I'll build this in stages, pull NASA data, download, blah, blah, blah. So it's going to go ahead and send all of this information. So you can see it creates like your little another folder here for you. So that way you can create an entire new structure there. So this is going to take a while. So instead, I'm just going to stop this so that way I can show you exactly what this looks like. So it's going to go ahead and basically go through and build everything out for you. Like I said, it takes a good couple of minutes. So because there's a lot of data it's pulling in, and afterwards it's going to have this beautiful near Earth swarm system, and you can always go back and forth and make any changes. Let's say you don't want to be able to see the orbits and stuff like that, or if you don't like anything, or if there's something that you want to add, you can just go back and forth with it just like you would with your normal Claude Code sessions there. Now, for those of you guys who are part of my school community, this is going to be inside the Claude Code Masterclass section. Again, I'm just gonna everything is there. You guys can just basically copy and paste a file that you can upload, and you'll be able to have this thing already built for you, so you don't have to build it from scratch yourself. And for those who are not, again, you're gonna have everything available for you completely for free, including the prompts and then also the settings that we just walked through. So hopefully you found this video helpful. Again, I'm planning to make more videos about GLM 5.2 because I think open source models are finally starting to catch up with the closed source, and this is something that's truly remarkable, and I think it's really going to change how we interact with LLMs in general. So hopefully you found this helpful. Make sure you like and subscribe because, like I said, I got more content in this space that's coming up that you don't want to miss. Thanks for watching, and I'll see you on the next one.